Okay, today we're going to be talking about section 1.3, and the concepts of 1.3 is to be able to use a linear function to model data. So modeling with linear functions, okay? When you guys were in algebra, you had different ways that you represented a line using equations, okay? So I'm going to write line equations that you know of. The most popular, okay, is the slope-intercept form. Y is equal to mx plus b, okay? And we use this when we have the slope and we have the intercept, okay? So when you have the slope and you have the y-intercept, I'll put y here, then we use the slope-intercept form. The next format that you might have is the point-slope form, okay? So this is one equation. The other type of equation that you have is the point-slope form, which is y minus y1 is equal to m times x minus x1, all right? And you use this when you have a point and a slope, okay? And of course there's other variations, but if all else fails, you always can create a formula by using one of these two forms, and if you have 2 points, because you only need 2 points minimum to be able to determine a line, okay? So if you have any 2 points, you can either use some calculation to figure out the slope, or you can use some calculation to figure out the y-intercept, or if it's stated as a point, you can use the point, okay? So these are the 3 main forms of information that you can use to find a linear function, all right? So I'm telling you this because when we have data, which we will experiment with during class, okay, and we plot it, okay, so I'm going to just do a really quick example of a scatter plot. When we plot data, sometimes we will end up seeing a trend, okay? And the trend will probably fall into some of the parent graphs that we've talked about before, but in this case, some of the trends that we're going to be looking at in particular are linear functions. So if we plotted a bunch of data like this, okay, we have all these dots, and it might be hard to see, so let me color them in a little bit more. But we can see that there is some kind of correlation between them that's happening in a positive fashion. So if I were to draw in kind of a line that best fits, okay, it would be something that looks like this. And this is called line of best fit. When you're given data that's kind of in a scatter plot form and you find the line of best fit, when you have a line, you can actually find the equation of the line by using one of these 3 forms up here. If you have the slope and the intercept, or a point and a slope, or even just 2 points where you can calculate the slope, all right? So let me go ahead and give you an example of that. Okay, so I'm going to erase this top part right here so that you can see the bottom. All right, so let's say, for example, okay, we have a situation where we have a cell phone plan. Okay, so we have an example of a cell phone plan. So I'm going to use cell phone plan example. Okay, the first is we have 2 plans. Okay, let's say you have one cell phone company, and I know that there's a lot more involved in a cell phone plan than just this, but this is just a simple example. Let's say we have company A, okay, and they charge you $100 as an initiation fee or whatever, an installment fee, okay, and then for every text message that you have after that, so your text message is going to cost 10 cents per text. I know, not truly realistic because nowadays we have unlimited data plans. And then we have company B, where there is no installation fee of any sort, but they just straight up charge you 25 cents per text messages, which would be insane given the number of text messages people use nowadays. So let's say we have these 2 companies, and we want to find out 2 different things about them, okay? The first one is how long we have to have the phone in order, well, let's just find the first one. how long will you have to have your phone in order for these two plans to become even? Okay, so the question that I'm asking here is, how long do you have to own the phone for plans to cost the same? The same. Okay, so that's the question. Okay, so let's go ahead and create a linear equation for both of these situations. Okay, so I'm going to create these equations using three formats. Okay, these are the three ways that we usually describe mathematics. Okay, we have the table. Okay, we have, and I'm going to write, these are different formats of representing our data. Okay, we have the graph, and we have the equation. All right, so the table's pretty easy, okay? And I'm going to squeeze this down here. We have, so let's say we have A, company A. The table that we have here for company A, okay? Let's just say we have the number of text, all right? And, oh, actually I have to change my domain. The number of text is going to be here. Text, okay? And then this is how much it's going to cost. So with 0 text, we already have to pay $100 as our initiation fee or installation fee. After 1 text, it's going to be $100, and 1 text is 10 cents. After 2 texts, it's going to be $100 plus 20 cents. 3 is $100 and 30 cents. Okay, so that's the table representation for company A right here. Now, if we were to graph it, and I'm just going to do a quick sketch, it's going to be tight, but I'm going to scoot it over here. Okay, for company A, the graph, and I'm just going to do a really quick sketch so you see, it's going to be at $100 because when we have 0 texts, we have to pay $100 right off the bat. And then it's going to be just kind of a rough estimate, like about 10 cents each time we add a text. So the graph is going to be something that looks like this, okay? Where it's 100 here, and then it's going to be $110.10 here, $110.20, and so on, okay? So the equation for company A, we know that our y-intercept is going to be at 100, because that's how much you start with at the beginning. And then every text message, or X, that you have is going to be charging another 10 cents. So I'm going to use, because we have the intercept and we have the slope, which is 10 cents each text message, it's best to use our first equation, which is slope-intercept form. Y is equal to 0.10x plus 100. So that's going to be the equation representation for company A. Now, if we talk about company B, all right, if we talk about company B, the table representation for company B, okay, is going to be, again, the number of text messages and how much it's going to cost. So if we make 0 text messages, it's going to cost nothing. But if we send 1 text message, it's going to cost 25 cents. If we send 2 text messages, it's going to cost 50 cents, 3, 75, and so on. Okay? So if I were to do a really rough sketch to represent this data, 0, 0 is here, okay? And then 25 cents, so it's going to be slightly steeper, okay, than our previous graph, which is going to rise 10 cents each text message we have. This one is rising 25 cents every text message we have. So a rough sketch of this is going to look like this. It's going to be still a positive correlating linear function, but it'll have a higher slope. So if we were to represent this, we have a y-intercept at 0 and a slope of 25 cents each text message. So it will be y is equal to 0.25x plus 0. Or in other words, if you want to write it simply, y is equal to 0.25x. All right? So what I've done is I've represented these 2 phone companies in 3 different fashions, which are the 3 ways that we look at math most commonly. is by table, so data points, by graph, and then also by equation, okay? And this is going to lead, this question of how long do you have to own the phone plans to cost the same, this question is going to lead into the next section, which is how to solve for linear systems, okay? So I'm going to go ahead and erase this example right here, hoping that you have that information of the problem marked down. And we have a system basically, so to solve this question right here, to solve, we need to set up a system, okay? So we're going to set up a system where we're solving for multiple variables at the same time, okay? So the system that we have is y is equal to 0.10x plus 100, and y is equal to 0.25x plus 0, okay? Now, there's a couple of methods that you can use, which I actually will lecture about a little bit in the next video, and I'll leave it as is, but see if you can try to solve for this equation. You can either graphically graph them accurately somewhere and see where those intersection point is, and that will tell you that at that time how much the phone plans are going to be at the same time, okay? Or you can use graphing, or you can use substitution, perhaps set this equal to that, or you can use the process of an elimination, trying to eliminate a y or eliminate an x of some sort, okay? So I'm going to stop here, and I'm going to challenge you to see if you can solve the system, the simple system of two variables, and we're going to continue to take this on to 1.4, and we're going to start solving systems with even more variables than 2. 3, theoretically, once you can do 2, you should be able to do x number of variables. All right, so enjoy.